Hi. So today we will be looking into pointers. So pointers are basically same whether it's in terms of embedded C or normal C coding standard. And also it is very important to understand pointer with respect to our interview perspective. See, pointers tell you the exact concept how the memory in and a computer or an chip or an in IC are used. So it's very important to understand those concepts. So we will be starting with pointer basics, so where I will be explaining you what is pointer, how it is declared and how it is used. Then we will be looking into memory layout. So memory layout is basically where we see the structure, like how the memory is being structured, which part of memory is used, where pointers will be placed, which location pointers will be pointing out. Okay. Then coding with pointers. Here in coding with pointers we will be looking into how to use pointers in our coding. Okay, let's start with the pointer basic. So the first point here is pointer stores the address of a variable. So let's understand what does this means. So a pointer we is defined by like this: ptr equals to ampersand of a, and we have to first define a equals to 10. So this int here is the type of the pointer, and ptr star denotes pointer and ptr denotes variable name. This ampersand signifies it will be transferring the address of a. Now when we defined a equals to 10, that means a is mapped to an address, let's say 0x08123, and this stores a value 10. Similarly, ptr is mapped to an address 0x08423, and it stores the address of a. It's like mapping to this. So in simple manner, a is pointing to 10 and ptr is pointing to a. ptr is not pointing to 10. So that's what the pointer stores: the address of a variable, it doesn't store the value. So second point we'll see. So second point here we see is that pointer declaration takes by 4 bytes of memory. So what does this mean? Pointer declaration takes 4 bytes of memory. Let's see. So when we define a pointer as int star ptr, so this pointer will also store in the memory location, and to store this pointer 4 bytes of memory is used, and this 4 bytes depends upon the type of system we are working with. So 32 bytes, if we say 32-bit system, then it takes 4 bytes of space to store a pointer. If it is a 64-bit system, it takes 8 bytes to store a pointer. And remember, it doesn't depend upon the type of pointer. That means whether it's a characters pointer, whether it's an integer type pointer, whether it's a long type pointer, all of them will take only 4 bytes in the memory, whereas character chr, a, int b, long c, this will take 1 byte, this will take 4 byte, bytes, and long will take, I think, also 4 bytes, like this. So it doesn't depend upon the declaration in case of pointer, it's only depends upon the type of system it is used. So it will take 4 bytes for 32-bit system and 8 byte for 64-bit system. His pointer can hold the address of function. These pointers are called function pointers. So if we say we have a function int sum, int a comma int b, which returns a plus b, then int in brackets star fptr means function pointers, int comma int is a function pointer, and we can say for now, then we say fptr equals to sum. So fptr will be pointing to sum. So how it is happening? So everything that is a function or a variable will be stored in a memory location. Let's say the sum is located into 0x084567, and fptr will be pointing to this location. Okay, and to call this function we simply have to write fptr in space 5 comma 6, and it will also return a value. Let's say we say int sum 1 equals to, this will give us the value of that function after solving it. Okay, function, any pointer that stores the value of a function is called a function pointer. So then again we will see it, don't worry if you don't understand it, we'll see into the coding section. Then we see that a pointer are initialized with the null, which means it points to a location that does not exist. Okay, so it is also important why we say a pointer is initialized with a null, and that location doesn't exist. So it's important in terms of interview also. So let's understand it. Int star ptr equals to null, and int star ptr1, these are the two things. So first thing is this is initialized, and this one is non initialized. Okay, now what's the basic difference? So this ptr1 can point to any address as a garbage value, and any, this is like an unintended thing. Like as a developer or as a coder, we don't want unintended things to happen. So that's why we say the pointer should always be pointing to null when it is not reference to any specified memory location. It's just to avoid any type of error to occur. So remember this whenever you are asked in a interview why we say, why it is pointer, always pointer has to be initialized with null, because we don't want any errors in our code while running for a pointer to point to an unauthorized location or to an unintended memory location. Okay, so now let's go to the next thing is, to access the value at a location we have to dereference the pointer. Okay, so what does this mean? This means if we say int a equals to 10 and int star ptr equals to ampersand of a, That means we have a value 10 that is pointed by A, and A is pointed by PTR. So we are not able to get the value 10, right? But how we should get the value 10? We need to dereference it. Like we first say, okay, what does pointer contains? Go to A. Okay. Now, what does A contains? Go to that value. Then we get 10. So this is called dereference. We first reference to A, then we again reference to what is inside A. So that is called dereferencing of pointer. And how it is achieved? Simply, like we can say star ptr is give, will give, if we say int b equals to star ptr, then b will be having the value 10. So that is the main thing. So this is called dereferencing a pointer when we put star in front of it. Now there is another thing that I want to explain. For a pointer, it always stores the starting address of a variable. What does this means? Like int is 4 bytes. So if we say it's a 4 byte, 1 2 3, okay, 1 2 3 4, these are bytes. Every byte will have individual 8 bits. 1 2 3 4 5 6 7, okay, one more, 8 bits. So the pointer will always point to the first bit, that is this. Okay, if we say int ptr, okay, so pointer will be pointing to this. This is the starting address we say. Okay, and this int of a pointer defines up to how much of memory it can access. So that is defined by the type of the pointer. So just remember, pointer always stores the starting address, and it can access up to the type of the pointer or the type of the variable address it is storing. Okay. So if we say it's a character pointer, star chptr equals to, we defined a character, let's say ch underscore equals to b, that, and we say ampersand ch underscore. So ch underscore will be targeting to the, will be pointing to the starting address. So as we know that character has total 1 byte. So 1 2 3 4 5 6 7 8. So ch will be pointing to this one, and when we try to access, it can access all the 8 bits depending upon the type it is using. Okay. Okay, we start with the memory layout. It's an interesting part to understand. Like whether we are working on a desktop, laptop, or with a mobile phone, nowadays with any device, we have two parts, right? One is RAM, another one is ROM. So RAM is the one which is the processing memory, like how fast your system is depending on the RAM of the system. And ROM is the basically the flash area, or where we are storing the data. So if it is an for the embedded purpose for a microcontroller, RAM will be the processing part of the a memory, and flash or ROM will be the part where we will be having the storage area, like where code will be stored or the constant variables will be stored. So any device will typically have these two things, RAM or ROM. So first point, let us understand what is RAM. So in your laptop, you could see that there will be two things. One is the RAM. You will be connecting to the RAM slot, uh, and then there will be your hard disk, right? So in this case, hard disk is the ROM part, that is the fixed memory, and this is the RAM. So if for processing, always RAM will be used. So when you write a code, let's say int a equals to 10 and int b equals to 20 and c and int c equals to a plus b. So this a equals to 10 and b equals to 20 will be stored here, and c equals to a plus b will be calculated using the RAM section, and the data will be stored inside c, and this variable will be in the RAM. So that is how the processing happens. For processing, the RAM is very important. So in any system, this RAM and ROM will have different address starting area. What does this means? Typically for a microcontroller, a RAM will start from 0x02000000, and the flash or the ROM will start from 0x800000. 1 2 3 4 1 2 one more, 1 2 3 4 1 2 3, yeah, like this it will start. Okay. Now what another thing is, RAM is expensive where ROM is less costly. Why RAM is expensive? Because for processing we need to read and write the RAM area multiple times. Like, so if we have let's say you have 2 GB of RAM, right? And you want to play a game, that game takes graphics and functions and everything, that at a time takes let's say 1 GB, 1.5 GB of space. So what processor has to do? Processor will has to take almost 75% of your system, and it has to always like load, erase, load, erase, load, erase this area, right? So it has multiple time write capabilities. So RAM is costly. So but whereas the hard disk is less costly, and it has a very less number of rewriting time. That's why you should know that you should not format your system every time and very often, so it will damage the life cycle of your hard disk. So that's why, like, how in ROM what happens is, like, when you store a memory, it will just shift the pointer. So first this this area will be storage will be used, then the pointer will shift to here, and then this area will be used, then pointer will shift to here, then this area will be used. Whereas in ROM, as the area itself is very less, so every time the pointer has to rotate itself. So after using this area, it has to come here, clear this area, sorry, clear this area, and then again use it. So that's why. So just remember one thing: RAM is processing, multiple read write, read write, and costly. Whereas ROM or flash is storage and less number of read write. For embedded, just remember, all constant and initialized, then code will be sitting in the ROM area or in the flash. All non-initialized, stack, heap will be in the RAM area. So this non-initialized variable cannot be too high. That's why we say, like, in a code use minimum number of variables required, right? So that's the reason. Okay, so we have reached to the last point, that is coding with pointers. So let us start. So I am using an online code editor. So it is easy for you to also start, go to this website and start an online code editor. So first thing, we should see like what's pointer, how we define it. So int a equals to 10, and we can say int star ptr equals to ampersand of a. So this is how we define a pointer, and we assigned the value to the pointer. So address of a is stored there. Now we want to print f percentage d star ptr. Now, if we don't give start and just try to print PTR, then it should print the address of A. Let's try. See, it prints the address of A. It is saying something long ls. It should, we should give it. So that's why it is printing the address of A. If we give star A and try it, then it gives the value of A. And this thing we can verify using, let's give ampersand ampersand of A and remove this. Just give a slash n. See, both the addresses are same, right? Because ampersand a is storing this address. Now, one another interesting thing, as I defined, like, we are always storing the starting address of that variable, right? So what we can do is, I can define a array, let's say 4 comma 8 comma 7 comma 6, right? So this is an array, and now in the similar manner I am storing the address of a, that is the starting address of array. Okay, so if I just print it, so let's see, it is the starting address, this is the starting address. So now I try to print the value, first value. So see, first value 4 it is printing. Now let's try to print the second value. Keep it simple, I'm just putting it plus here ptr equals to ptr plus 1, right? Let's see what it prints. It prints 8, so it shifts to 8. So why this is happening? Because ptr points to a, and when we say ptr plus 1, then ptr jump by 4 bytes and it goes to this location. It's like it's like if we say int a 4 5 6, so it's typically like a is pointing to a location which starts from 0x080000, and it has 4 in it, then 5 in it, then 6. Now we have a pointer, that's mean ptr points to this address. And when we say ptr equals to ptr plus 1, it means it will jump to the next address, that is 0x080001. Here 1 means 1, sorry, it will jump to next address, that is 3. That means it will jump by 4 bytes. So every pointer when incremented by 1 will be jumping to the next size or the next address defined by the type of pointer variable, like the type of pointer variable it is in. Okay, next thing is function pointer. So let's write like void sum int a comma int b, printf sum equals to percentage d a plus b. Now we move everything, and if we just say sum 5 comma 6, see, so it gives sums equals to 11. Now instead of this, what we need a function pointer. So it is a void type of function, so we need star fptr, and we defined int comma int. This is the argument of the function pointer, and here fptr equals to sum. Remember this, name of the function is itself a pointer, so we don't need to put an ampersand like this in front of it to pass the address. We can simply pass the address, and then just we can write f fptr 5 comma 6. Okay, remove this. Okay, just run it. So it also gives the same value. Modify it to 5. Run the code again. Okay. So this is all about the pointers. This is called a function pointer, which points to a function. Similarly, you can also create an array of a pointer if you write. Let's see, we say like void, copy the whole thing, and just put sub to subtract sub is a minus b. Okay, and we define like this as a function pointer, and here we just give the different function name sum and sub, and then if we try fptr 0 5 comma 5 should give 10, right? And if we do 1, then it should give 0. So like this you can also create an array of function pointers. Thank you.